let's begin. Today we're going to deep into chemical biology and thinking about specific discussions on a drug-protein complex. We're going to think about how a particular drug works on Parkinson's disease. Xavier?
What is Parkinson's disease?
Well, that's a great question. I was about to get to that one next. Parkinson's disease is a neurodegenerative disease that primarily affects dopamine-producing neurons in a specific area of the brain that can affect movement. Dopamine is responsible for sending messages to and from the brain to control or plan body movements. Common symptoms of Parkinson's disease are hand tremors, rigid muscles, and balance control.
Yes, sir?
What type of drugs are on the market for Parkinson's disease?
There's nothing that can cure Parkinson's disease right now, but there are many drugs that can alleviate some of these symptoms. The leading one is levodopa, or L-Dopa, which is the most effective and widely used drug at treating Parkinson's. It works by raising the dopamine levels in the brain. However, there is a new drug that we'll be talking about today, Safinamide, which, sorry class, is commonly associated and sold under the name Xadago.
Yes, Osha?
How is this drug effective in treating Parkinson's disease?
Now that's a great question, and we can go right into a top hat question to answer that.
Given the following enzymes and their function, which enzyme is inhibited by safinamide?
Alright, let's see which one's the correct answer to this top hat question.
The correct answer is A.
Let's dive into this explanation some more. Does that all make a bit more sense? Any questions from the class?
Yes, Xavier?
What is MAOB, and how does safinamide and other drugs know how to target it?
Another great question. I am so surprised by the input in class today. I see we are really excited about this drug interaction. Well, MAOB is a protein that catalyzes the oxidation of monoamines. This oxidation happens on neurotransmitters usually. MAOB is used to break down dopamine in the body. Excuse me, class. As I have stated before, Parkinson's disease patients have lower than average dopamine levels, therefore safinamide inhibits MAOB to maintain these higher dopamine levels. Safinamide and other drugs can target the MAOB active site by having a complementary non-covalent interactions. In particular, the MAOB active site has lots of aromatic residues, such as tyrosine and phenylalanine, that can form favorable pi-pi cation interactions.
Ooh, another one. Yes, Osha?
How does the protein and drug interact?
Time for another top hat question. I was feeling a bit snarky when I made this one.
Which functional group with the safinamide molecule will interact through intermolecular forces with the Q206 residue on the MAOB enzyme?
Let's review the correct answer for this question.
The correct answer is D.
So class, now that we've learned the targets and desired functions of the drug safinamide, it is time to learn how the drug accomplishes these things. Let's think about the mechanism of action. Hey Xavier, why don't you come on down and let's demonstrate how safinamide blocks this MAOB enzyme.
I'd be happy to.
Thanks Xavier, you're a real good sport. So first, I am MAOB and you will be safinamide for this case. So you're going to block my enzyme from eating the dopamine, which will be these pencils on the ledge. Now let's show how it works.
No, stop. Don't need any more pencils.
Let's do another top hat question to ensure that we understand this mechanism fully.
Which statement best describes safinamide's mechanism of action? The correct answer is D.
Finally, let's discuss the molecular interactions present in the drug safinamide.
Wow, another one. Yes, Sarah?
What exactly do you mean by molecular interactions?
These interactions are non-covalent interactions such as pi-pi, dispersive forces, hydrogen bonding, and many others. These each come from different functional groups within the molecule. Well, when you look at that, it's almost 5:15, but I think we have time for one more top hat question.
Circle the H bond acceptors and put a square around the H bond donors. The correct answer is B.
Great questions today, class, and I hope you all liked today's lessons on chemical biology and the drug safinamide.